Welcome back to the Oracle Mobile Application Framework YouTube channel. Together, we will examine the code of an application today. This will help you learn various techniques used in real-world development projects that use the SQLite integrated database. There are three main tasks related to the local database that require you to write business logic. First, database initialization. If you want to create the database file the first time the application is run, you will need to write some code. This code can contain hard-coded SQL statements, although I recommend to store them in their own file and read the file at runtime instead. I will demonstrate this technique later in my demo. The alternative is to use a preceded database. This means you basically create a SQLite database on your desktop and then package it inside the application. I will also show how you can do that. The second task is, as you may guess, data access. Typically, you will need to write data access code using the JDBC API in a plain old Java object or POJO. You will then generate a data control from this POJO class and typically consume it in AMX pages through drag and drop. Finally, you want your application to be able to fetch data either from a web service or the local database by checking specific conditions. For example, you could query the database when there is no network connection available and make a web service call otherwise. Such logic is easy to implement and simply requires to create a data control for the web service call using the wizards offered by your favorite IDE. Let's now have a look at the structure of an application that performs all three tasks. 1. We initialize a new database by executing a SQL script when the application is started. This is achieved through a properly registered listener instance called Lifecycle Listener IMPL. 2. Our application contains a custom data control built from a POJO. This POJO uses JDBC in order to access the database. The name of the POJO is country.dc and it uses the country.bo class to represent the data. And finally, this data control is bound to the user interface. It contains business logic to ensure a seamless transition between a live web service call and the local database according to network conditions. The web service interaction is handled by another data control called HR_WS. For this demo, I will use Oracle JDeveloper 12c. But enough talk for now. Let's get to work.
Okay, so this is the application I told you about. Now, what I will do, I will first show you where you must register the lifecycle listener in order to initialize the database when the application is first started. So we go to the MAF application descriptor here, and we see lifecycle event listener. So a class has already been selected. This class is part of a project in the application, the application controller project. So if I open it, so we see here I put some code here in the start method. So the start method is only executed when the application is launched, which means if you start the application, switch to another one and get back, the start method will not be executed. So what I'm doing here is very simple. I'm calling a method called initialize database from script. And then I do some exception handling. So basically, I record in the application log any exception I could have got. So now let's go to initialize database from script. Okay, so this method reads the SQL script somewhere in the application package and will create the SQLite database file on the file system. So what do we have here? First, okay, we get the path to the application installation directory, and then we concatenate that, okay, in a variable called dbName. Then we use the Java IO classes to check if the database exists or not. If the database file exists, we simply exit. If the database file doesn't exist, then we must get a database connection and then create the actual database tables and put some data in it. Okay, so here we get the connection. Okay, so that's JDBC SQLite, exactly like I told you. This is a JDBC URL, and we set auto commit to false. After that, we've got a block of code where basically we read the database script. So in order to achieve that, okay, we access the context class loader and access the file as a stream. And the file, we put it in meta-inf, and it is called initializeDB.SQL. So if I have a look at my application control project here, I see the SQL script. If we examine it, this SQL script, we see that, well, it's fairly standard. What we do, we enable foreign keys and then declare or enable auto vacuum in order to prevent the file to take more space than it should on the device's storage. Then we create two tables and put values in each of those tables. And that's it. So what I will do now, okay, in this block is to read this file as a stream, and then we create a JDBC statement, and for each line, okay, because we see we've got a buffered reader here called script reader. A buffered reader will read a stream line by line, okay, according to the line breaks in the file. So now we read each SQL line, and if the line doesn't start with commit or rem, then okay, we simply execute it. Okay, so what will determine the statement to execute is the presence or not of a semicolon at the end of the line, which is a standard SQL convention. Okay, so here we execute the statement, and then we clear the string buffer we were using in order to hold that specific line. So each time we create a new string buffer. Okay, so that's what we've got for database initialization. Now, once the database has been initialized, we need to write some logic in order to access the data from inside the application. And this is done in the view controller project. Okay. Now, to hold my data, I told you already, I've got a country BO object. Okay. So this object mimics the structure of the database table. So I've got only 3 attributes, and then getters and setters for those attributes. Now let's have a look at the base class for our POJO data control. So this is the POJO for the data control. First here we have a constant. Okay, so not reachable means there's no network connectivity. This is what MAF would return to my business logic when there is no network. So I declared it as a constant at the top. Then we see get countries, which returns an array of country BO objects. Okay, so this is the method that will be bound to my user interface. So the thing is very simple. We see that, okay, we first declare a null instead, a reference to a list of country BO, an array of country BO objects, and then we check the network status. Okay, this is done by evaluating a specific expression language expression. We see it here. So that's device scope, hardware, network status. Okay. And then if the network status is not reachable, which means we have no network connectivity, then we call the getCountriesFromDB method. Instead, if there is a network connection, I call getCountriesFromWS. Obviously, I could be more granular here. I could have a different behavior when there is a Wi-Fi connection or a cellular data connection. But in this case, whatever type of connection I've got, if there's one, I will try to call the web service. And then I simply return the list of countries I've got. So getCountriesFromDB. Okay, so this is where I simply make a query to my local database. So first, I get a network connection by using my connection factory. Then I simply create a statement and I execute the query and put that query in a result set, a JDBC result set. And then I iterate on the result set. Okay, so as long as I have a new row in my result set, I create a new country BO object, and then using the setters on this country BO object, I read the row, and I'm using the typed JDBC getters. So I know that country ID is string and country name as well, and the region ID is an integer, so I call getInt. Okay, so that's fairly simple. Thing is, if I had wanted maximum performance, I should have used the indexes for those columns. And I mean, this is number 1, this is number 2, this is, okay, number 3 in my query. Okay, so those are the column indexes. So for maximum performance, I should have done that. But for clarity here, I'm spelling out, okay, the full column names. And at the end, I simply add my new country BO instance to my return value array list, because this is what I'm doing here. So I'm using array lists internally, but I'm using arrays externally, since arrays are easier to manipulate. Okay, and now exception handling. So if anything happens while executing the query, I will simply log the thing and then throw a runtime exception, because normally this should never happen. This is not necessarily a recoverable situation, so this is why I'm doing this. And this last line will transform the array list I had in an array. So return value to array, and I'm declaring the new array I need, which is an array of country BO objects, which has the same size of my array list. And that's it. So this is the class for my the POJO for my country DC data control. And if I have a look, okay, here we see that I've got a data control that uses that POJO that returns a country collection, and we see country ID, country name, region ID, exactly, okay, as in the country BO object. Now, the last step is to bind the data control to a screen. So what I did was simply to create a page inside the task flow. Okay, so we see my task flow here, and it's very simple, a single page. And if I have a look at the page, okay, we see that there's a list view using the bindings, countries, collection model, binding entry. Okay, so basically I drag and drop countries here, and I selected list view in the contextual menu in order to build the user interface. Okay, so that's straightforward. Here we see that I'm displaying in the screen, okay, the current value for device, hardware, network status. Okay, so this will show you in real time when I will demo the application what exactly are the network connectivity conditions on the application. One of the design choices you have to make when you create a MAF application that will use the local database is whether to initialize the database using a script, and that's what I already showed, or to use a preceded database file. So a preceded database file is one that you have created on your desktop or laptop computer and then packaged alongside the code for the MAF application. So this is an example method, okay, that shows how to deploy properly a preceded database file when you start the application. So it's called by the lifecycle listener implementation class, once again, okay? And the start of the code is very similar to what we have already seen. So we get the path and we simply create or concatenate the name for the database file, the target database file, and we check if it exists or not. If it doesn't exist, we see here we acquire a stream, but instead of acquiring a stream to a SQL script, we see that in meta-inf we have preceded _hr.db. Okay, so this is a full SQLite database file that has been created. Okay, and what we do here, we simply copy, okay, the file using a file output stream. So we read the bytes for the original file and write them at the correct location. In order to use a database file, you shouldn't leave it inside the structure of the application, but you should deploy it to the application's install directory, exactly like you would do with the database that has been created from a script. Okay, this is really important. And that's it. There is exception handling. So whatever happens, okay, we close the source and destination streams once we are done. So this is very straightforward. Now, in order to create that preceded file, you need to use a tool. So there are a variety of GUI tools that you can use, and some of them are free, some of them are open source, and some of them you must pay for them. But in this case, I will use the SQLite shell that you can download from SQLite's website. So this is a command line utility like SQL Plus, and it will enable us to create a SQLite database file on the desktop. The SQLite command line shell is very, very simple to use. So let's now create a new SQLite database from scratch using it. So I start the shell, okay, and by default, okay, it will create for me an in-memory database. Okay, so nothing will be persisted to the file system. So commands in the SQLite shell always start with a dot, commands that are not SQL commands. So what I will do, I will exit, okay, and then restart the shell, but by specifying a name for my database. So in this case, everything I will do will be persisted, okay, to that specific database. So now I could, for example, create a new table. So create table test, and then we have and now I can check that the table has been created by using this SQLite command, and we see that test has been created. Let's add a record to it. Okay, and here obviously I've got a syntax error. because I forgot to specify values here. So the shell will validate the various commands you type and will give you feedback exactly like SQL Plus would do. Okay, now if I do a query, I will see that I've got a nice record here in my database, in my table. Okay, simple enough. So now let's do something else. I will use, okay, we see that I've got the initializeDB.SQL script I had inside my my MAF application. So now what I will do, I will use the command shell to run the script. And this is very, very easy. So I will create a database called hr.db, but I will input the contents of the script to the shell. So what the shell will do is that it will execute my SQL script. Okay, and now I will connect to that new database that I have just created. So SQLite 3 hr.db. And if I check the tables available, we see that I've got countries and regions. So if I run a query, I see all the countries that had been defined in my SQL script. So as you can see, the shell is straightforward to use. There are GUI tools that you can use, but in most cases, the shell will be enough for your purposes. Personally, I'm always using JDeveloper to craft the script. And then once I'm ready, I will simply use the SQLite shell in order to run it. So don't hesitate to use whatever tool you're comfortable with. But as you can see now, I've got my hr.db file here, which has been initialized. And now I could copy that inside my MAF application and use that preceded database instead of running a script.
Let's have a look at the finished application running on my Android phone. By default, the application shows data coming from a web service. So you see here the network status, okay, shows that I've got a Wi-Fi connection. So now I will activate airplane mode, which obviously will remove all network connectivity. You see the network status has changed to not reachable. When I click on the refresh button, then I'm fetching a different list of countries from my local database. So in this case, this really shows that the data comes from the database and not from the real-world web service, which returns a list of real-world countries. This is the end of the demo and of the episode. I hope you enjoyed it. Building MAF applications that use the local database is very productive. The JDBC API is straightforward and it is easy to write business logic that will change the source of the data according to operational conditions. This, in turn, makes your user interface simpler and easier to build. I'm Frédéric Devier. Thank you for watching.